Good morning, guys. Hopefully you guys are doing all right today. We start with green check marks. I know there's only a couple of you in right now, but we're just going to power through because we are rolling. We're rolling through Unit 1, and we are hopefully going to finish Lesson 3 off today. And next day on Thursday, we'll do Lesson 4. Get this unit out of the way. Josh is there. Is Corbin there? Thanks, Josh. While we're waiting for Corbin, do anything exciting on the weekend, Josh? No. Yes. Thanks, Corbin. All right. I have a feeling a few more people will be here shortly, but we'll just go. We'll go. You want rock climbing like outside or inside? I love rock climbing. When I was in university, I went to the Beyond the Crux rock climbing gym. I did a lot of bouldering. And I actually live in the Mission. We went up to the boulder fields inside the Crux. Perfect. Yeah, there's a place up on the south slope, south end of Kelowna. It's called Boulder Fields, and they've got all these climbing routes, and it's all, they've got like anchors drilled into the rock and stuff. It's pretty cool. If you get a chance and you like climbing, head out there. But the Crux is a cool place. I went there for a couple of years, bouldering. I really miss it. It's just one of those things. You got to find time. All right, so where are we? Where we're going? Just a reminder that you guys will have your midterm exam on Thursday next week, which is the 3rd. So it's about 9 days from today. I'll talk about it a little bit more next day, but for now, we're just going to look at where we are. So last day we kind of went through rate, ratios, and proportions. Today I hope to get through unit pricing and sale prices. And I put this little quiz in here, which I'd like you guys to do. It's just 5 questions on the first 2 lessons. I don't think there's any sale prices stuff on it. Just easy peasy, just for you guys to get a little something in the middle of the unit. Today, sale prices and unit pricing, not terribly difficult. And then next day we're going to go through currency and exchange rates. That'll take us to Thursday, which means that you guys should be done this unit before next week. Now, some of you have finished. I'm just going to speak like everyone's here because I'll assume people will watch the video after the fact. Some of you have finished Unit 3, which is the stuff we started on with systems of measurements and surface area and volume and stuff like that. For others, we haven't finished it, so you guys need to get that done as soon as possible because we're going on without you, whether you like it or not. So there you go. I'm going to go right into the learning guide. Do you guys, either one of you, have any questions from the learning guide from last class? I asked you guys finish kind of up to the end of page 8, essentially. There's a little bit of unit pricing and stuff in here that we're going to do today. But the first like 35 questions, I did a bunch of examples, and then there was some try these, which I asked you guys to do. If you had any questions when you're going through those that you'd like me to do, I would be happy to go through them with you. If not, I will continue on. Nobody's typing? All right. So what we're going to do is just continue on with the learning guide. Unit pricing, page 8. I talked about this a little bit at the very beginning of this unit where I said I love going to Costco because they have unit pricing on everything. Literally every sign at Costco. Next time I go, I'm going to take a picture of a bunch of them and show you guys so you don't think I'm crazy, but every sign at Costco has a unit price. It tells you how much a sheet of paper towel costs for one sheet of paper towel. Or if you're buying like granola bars, it tells you how much a granola bar costs if you buy a big box. Or like pasta sauce, and it's like if something that's measured in weight, it tells you the cost per gram. If it's a volume, cost per milliliter. For literally everything in the store that's food related. I'm not sure if like the toys and stuff have unit pricing. They might, I don't know. Cost and throw them in chat. I'd be happy to go through them. 33 for sure. So Costco has unit pricing on everything, and I really like it. makes shopping, comparing prices really easy. We're going to talk a little bit about how to find out the unit price of something today. And we're going to talk a little bit about sale pricing. And sale pricing is kind of important because when you guys are shopping, if something's on sale, it's important kind of be able to think about what that sale really means and how to work that out, not only in your head but on paper. Sometimes a sale seems like a really good deal, but it just might not be that much of a savings. If they jack the price up and then put it on sale, did it really end up any cheaper than if it was just regular price sort of thing? So we'll talk a little bit about that sort of thing. Just the one question there, Costin, just number 33. If there's anything else, you could just put 33 and 21 or whatever. But while you do that, I will go to 33. John sells iPods at a mall. He sold 1 on Monday, 2 on Tuesday, and 4 on Wednesday. He sold the same number of iPods Thursday, Friday, and Saturday. If he sold a total of 16 iPods that week, how many did he sell on Friday? What proportion of his weekly sales was on Friday and Saturday? This is a really confusing question. See if I can wrap my head around what this is actually trying to ask. So he sold 1 on Monday, 2 on Tuesday, and 4 on Wednesday. He sold the same number of iPods on Thursday, Friday, and Saturday. I'm not sure I really understand what this sentence means. I think I'm getting kind of hung up on the same number. The same number as what? The 4 on Wednesday? Yeah, I don't know. All right, let's go. I'm just going to draw a little table. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. All right, it says he sold 1 on Monday, 2 on Tuesday, and 4 on Wednesday. He sold the same number of iPods Thursday, Friday, and Saturday. Like 4, does that work out? 4, no, 16, 17, 19. If he sold 16 iPods that week, how many did he sell on Friday? That doesn't work then. He sold the same number of iPods Thursday, Friday. Oh, I see what you're saying. The amount of iPods on Thursday, Friday, and Saturday is all the same. Okay. Whew. They're not making this easy on us. And the total number of iPods is 16. So however many they sold on, he sold on Thursday was the same number as Friday and the same number as Saturday, but we don't know what that number is. All right. So it says he sold a total of 16. So if I add this all together, I'm going to get 1 plus 2 plus 4. These all give me 7. And then I have 1x, 2x, and 3x's. And then this has to equal 16. All right, that makes sense. So the 7 he sold in the first 3 days, Monday, Tuesday, Wednesday. And then Thursday, Friday, Saturday, he sold the same number, but we don't know what that number is. And then we're told that the total is 16. So we have this kind of a mathematical equation here that we can get from the question, which is really weird because I'm not sure what this has anything to do with the other questions we've looked at, but we're going to just pretend like it makes sense, and we're going to go through it. 7 plus 3x is 16. Let's figure out what x is. So we want to isolate x, get it by itself. So this kind of gets into the order of operations stuff we talked about at the very, 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 very beginning of the course. We want to do everything we can to get x by itself, so we want to move everything away from x. So I'm going to subtract 7 from both sides. 7 minus 7 gives me 0. I get 3x. 16 minus 7 gives me 9. And just rewrite this up here. 3x is 9. I'm going to divide both sides by 3 to get rid of the 3. The opposite of multiplying is dividing. I'm going to get x is 3. So that means that on Thursday, Friday, and Saturday, I sold 3. So if I were to kind of just put that in here, 3, 3, and 3. That's 3, 6, 9, 10, 11, 12, 13, 14, 15, 16. So that works out. If he sold 3 each of those days, it would work out to 16 in total that week. All right, so that's the first part of the question. And then the second part says, what proportion of his weekly sales was on Friday and Saturday? So Friday and Saturday, he sold 3 and another 3. So together on Friday and Saturday, he sold 6 in total on those 2 days. His weekly total was 16. So that means he had 6 sales out of 16. And 6 divided by 16, it's going to give us a decimal. 0.375. So if I multiply it by 100, that gives me a percent. 37.5%. We're going to talk about percents today as well. So it might ask, the answer might look like something like 6 out of 16, or it might say 3/8 of his sales. It might say something like that, likely. It won't have it as a fraction because we haven't talked about fractions or percents yet. Bit of an odd question. I guess it took me about 4 reads through to sort it out. Did anybody have any further questions from the learning guide up to question 35? Anything you ran into issues with, troubles with, didn't understand, wanted help on, wanted to understand further? Negative. All right, if nobody had any questions beyond that, I will just continue on with where we left off last day. So this is the bottom of page 8. We're going to talk about some unit pricing. You know what I might do? We'll see who actually watches these videos. Thank you for coming to class today, by the way. I'm just going to scroll up a little bit. You guys all showed up, so I left you with a bunch of examples. And I know you likely tried a bunch of them, and maybe you've done them all, which would be really good. But let's say you didn't do them all. Let's say like you didn't probably want to do number 29, so don't worry about 29. So if you did 29, awesome. If you haven't done it yet, don't worry about it. Let's not worry about 32 either. Save you some time on that one. We've all done 33 together, so that's easy now. And let's not worry about 34 because it's about iPods and we just did a question about iPods, so why would we want to do another one, right? Right. 35 shouldn't be terribly difficult. And 35 is a question that we're going to look at in science class as well, so that'll come back again. So it's definitely worth doing 35 because we'll talk about the same questions. So yeah, if you haven't done those questions, 29, 32, and 34, don't worry about them. And we'll just kind of continue on here. So unit pricing is kind of what I was talking about at Costco. So unit rate is the rate or cost of one item or unit. So we've talked about granola bars. It's the cost of one granola bar. If we're talking about like, let's say I bought some pasta noodles, it'd be the cost per 100 grams or the cost per kilogram, depending on what units I was dealing with or how big of the pasta container I was looking to buy. So unit rates that you kind of encounter every day, speeds on the road, the speed limits and speed signs. 65 kilometers per 1 hour. That's a unit rate. It's how many kilometers you travel in 1 hour. So kilometers per hour. Chicken sells for $12.68 per kilogram. That is $12.68 for 1 kilogram. If you go to like a bulk foods sort of store in the grocery store, you get all those signs that you see is like 98 cents per 100 grams. That's a unit rate per 100. I guess that's not a unit rate because it's per 100. If it was per kilogram, it would be unit rate. You get the idea. Let's look at an example here. This one's kind of actually set up for us already. So Joan, shopping for a family of 5, which includes 3 teenagers. She always checks the store flyers for the best prices. She needs to buy some juice and sees that Safeway has 1.89 liter jug for $3.10. I think it starts talking about, oh, did I? $3.10 was 3 for $10. Thank you, Mr. Ross. I was really confused because the next question asks us to compare, and I wasn't seeing the comparison. So 3 for $10. How much is each liter of juice cost? That's what we're interested in. So they've already done a little bit of this for us on the top of page 9. They say, okay, we have 3 orange juices for $10. How much does 1 orange juice cost in terms of dollars? So this is the unit price, the price per jug of juice. You could flip the ratios. That's all they've done here is they've just taken the top and bottom. So you can figure out how many dollars per orange juice, or you can figure out how much orange juice per dollar. Sounds like really weird and different, but they do definitely mean different things. So 2 ways to set up the exact same thing. So the important thing here is that we have orange juice on the top, orange juice on the top, or dollars on the top and dollars on the top. Our units on the top need to be the same, no matter how we set up our ratio. As long as the units top and top are the same and bottom are the same, we're doing okay. The idea here is we want to solve for x. Now, when we write these equations out, it sometimes gets really confusing with all of the units and things. You have orange juice and dollars and all this. So let's just keep it really, really simple. I'm going to go 3 OJ over $10 is equal to 1 orange juice over X dollars. I don't like that. That looks even more confusing because this OJ kind of looks like I'm going to do it in a different color. OJ. It's a little bit easier. No, I need to cross multiply. That's the whole point of what we've been doing for the last few classes. I'm going to multiply the top on one side by the bottom on the other. I'll write it next to here. So I have 3 things of orange juice times X is equal to 1 orange juice times $10. So I'm going to have 1 times 10. And I've lost all my units now just because it kind of gets a bit messy. Over here on the right, 1 times 10 is just going to give me 10, so that's not too bad. On the left here, I'm multiplying this 3 by x, and in order to get x by itself, I have to do the opposite of that. So instead of multiplying, I'm going to divide. And if I do it to one side, I have to do it to the other side. So 3 divided by 3 gives me 1, which leaves me with x, and 1 times 10 divided by 3 is going to give me 10 divided by 3, which is 3.33. So what does this mean? Well, that means that 1 orange juice cost how many dollars? So this is $3.33 for 1 orange juice. So that is our unit price, $3.33 per OJ. I'll just get you started on the next one here, because maybe help you out. The flower shop selling roses for $21.98 a dozen. A dozen is, that's 12. Calculate the price per 1 rose. So what I'm going to do is I'm going to go $21.98 divided by 12. So that's dollars for roses. That's going to equal how many dollars for 1 rose? So all I need to do is just take this $21.98 and divide it by 12. So let's do that. 21.98 divided by 12. It's $1.83. And that is per rose. So each rose costs $1.83. Next question asks for how many, so just multiply that by 4, and you're off to the races. The rest of this is pretty similar. Yeah, I think you should be okay with 5, 6 is the next example. So on the previous page, we calculated the sale of orange juice 3 for $10. We found that it was $3.33 for 1 orange juice. June, our friend June, notices that Save On Foods also has a special on the same brand of orange juice, but the containers are 1.3 liters. So we've got a different size of container. And this happens all the time when you go shopping and you're looking and trying to compare something and you have like 1.5 kilogram of this and 1 kilogram of this and the prices are different and you get really confused. That's why unit pricing is important. So at this size of container, she's got 1.3 liters, 4 for $9. Whereas Safeway had 3 for $10, but the size was 1.89 liters. So we have a completely different size and we have a different price. And we're interested in which is the least expensive, the 1.3 liters at 4 for $9 or the 1.89 liters at 3 for $10. Whew. Now, this is going to look like a lot of work, but it's actually not terrible. The idea is if we could just figure out how much it costs per 1 liter, we could directly compare them. We can't directly compare them because you're comparing one container at 1.3 liters to one container at 1.89 liters. There's no sort of direct comparison there. So that doesn't help us to be able to compare the price of one container because the containers are different sizes. So what if if their prices are different? Well, it just kind of doesn't get us anywhere. So if we could figure out the price for 1 liter for each of the deals, Safeway and Save On, then we could, figure out exactly which one's cheaper. So that's the idea. That's what we're going to try to do. So solution, the unit comparison here would be 1 liter. So in each case, we need to determine the total number of liters in each situation. So what we're trying to do is find the cost per 1 liter. If we can find the cost per 1 liter, that'll allow us to compare them directly. All right, so at Safeway we had 1.89 liter containers and we had 3 of them. So we had 5.67 liters. So that is 1.89 times 3 gives us 5.67. All right, so that's kind of the first step. We had 5.67 liters there at Safeway. The second step here is, now that we know how many liters, we can find the unit price by setting up a proportion. That 5.67 liters cost us $10. We want to know how many liters can cost us $1. No. This is actually a typo in the course. This shouldn't be this way. I'm gonna change this. This should actually be 1 liter is X dollars. Instead of figuring out how many liters I get for $1, I want to figure out how much it costs 1 liter. So instead of X liters, I'm going to put the X on the bottom and call it X dollars. So what we're going to do is I'm going to rewrite this ratio the same as all the other ratios we've done. All right, so 5.67 liters is $10 is equal to 1 liter divided by X dollars. I'm going to cross multiply now. I'm going to get 5.67 times X is equal to 1 liter times 10, and then divide both sides by 5.67. If I do it to one side, I must do it to the other. So on the top I have 1 times 10 divided by 5.67. So I just really have 10 divided by 5.67. So I get $1.76. And that is per liter. So that's my Safeway. That's what I've done there, is I figured out how much 1 liter costs at Safeway. Now we have Save On Foods to deal with. Remember, the containers were different sizes. So in this example, I was getting 4 1.3 liter containers. So I have 1.3 liters times 4. 4 times 1 is 4, 4 times 3 is 12. So I get 5.2 liters in total. And I know that 5.2 liters cost me $9. And I'm interested in figuring out how much 1 liter costs. So I'll call it X. And this is looking the exact same as what I set up over here, except I just have a different number of liters and different price. I'm going to cross multiply again. 5.2 times X is 1 times 9, and then I'm going to divide both sides by 5.2. If I do it to one side, I must do it to the other. I end up with 9 divided by 5.2. This is going to give me the cost per liter. So $9 for 5.2 liters. And 9 divided by 5.2 gives me 1.73. Dollars per liter. So Safeway was $1.76 per liter. Save On was 1.73. The question asked me which one was a better deal. And it turns out that Save On was a better deal. And it was 3 cents per liter. I guess I could just write 3 cents. There you go. So 1.73 is better than 1.76. So you'll see the remainder of the questions here on this page 10 are all kind of the same thing. You're taking different sort of units that you can't directly compare. The next one here, department stores selling socks for $3.99 a pair. So you get 1 pair of socks for $3.99. You also get a 3-pack for $10.50 or an 8-pack for $27 or a 12-pack for $39. Seem like quite expensive socks. What is the unit price for each of the packages? So you can't compare them directly. You get 1 pair is $3.99 or 3 pairs is $10.50. You need to figure out how much 1 pair costs because you have a box of 3, a box of 8, and a box of 12. You got to figure it out per sock pair. So try to figure it out. All you're doing is taking the cost and dividing it by how many pairs you get. So I'll leave those for you to try. If you run into problems, let me know next day. All right, moving on. Calculating approximate cost without a calculator. This is funny. I always remember a story when I was in Physics 11. I had a teacher, and he always made us do calculations in our head. He's like, well, just try to do it in your head. Don't get me wrong, I really like the guy. I learned a lot from him, but he said this to us, and it was probably true at the time because I'm a little bit older than you guys, but he said, you're not going to walk around with a calculator in your pocket all the time. So you got to be able to do math in your head. And at the time it was probably true. You know, cell phones weren't really popular yet. You know, maybe like a few people had them, but not everyone. Now, literally, just about everyone I know, I don't know anyone other than like my dad, and even he has a cell phone, but he doesn't use it. Literally everyone I know has a cell phone. They walk around with it in their pocket, and I'm thinking it's safe to say that everyone on their cell phone has some sort of calculator. So this kind of estimation thing is funny because literally everybody walks around with a phone in their pocket, and just about everyone has a calculator on that phone. So literally just about everyone walks around with a calculator in their pocket. So is estimating important? Yes, it's very important because you don't want to be the guy that's like at the store and you pull out your calculator and start doing some calculations to figure out which is a better deal or how much tax you're going to have to pay or things like that. So to be able to just estimate based on just a little bit of mental math is something that's good, and it's a skill that needs to be practiced. My wife, she teaches as well, and she teaches grade 7s, and she like hammers it into them to try to do it in your head first and then go to your calculator. And when we're at home, she's really good at doing math in her head, and because I deal with a little bit bigger numbers in grade 10, I don't use I use my calculator a lot more than she does. So she always makes fun of me for using my calculator when I probably shouldn't. So this would be good practice for me too. So let's look at a couple examples of sort of estimating using our head. Unfortunately, it didn't fit on this page, but it is on page 12 at the top here. So 2 times 5.6. Now, if I just asked you to go, okay, what's 2 times 5.6 in your head? You'd be like, well, I don't know. Let's just break it down into sort of 2 parts. Instead of 5.6, let's break it down into 5 and 6. Those are kind of easy numbers to deal with. So instead of $5.60, what we've done is we've broken it down into $5 plus 60 cents. Now, if I asked you what's 2 times 5, you guys would say, oh, that's 10, that's easy. And if I asked you what's 5 times 6, what's 2 times 6, you'd say, oh, that's easy, that's 12. So we have 10 and then 1.2, and we add them together to get 11.2. So the idea here is that by breaking these things down, it should make these calculations a little bit easier. Same deal here. 1250 times 5. I say, okay, you need 5 of them. They cost 1250. How much is it going to cost you? Well, 1250 times 5. That's a bit tricky. But if we broke it down into, you could break it into 10 plus 2 plus 0.5. So to do this in our heads, you can go, okay, 5 times 10, and then 5 times 2, and then 5 times 0.5. 5 times 10 is 50. 5 times 2 is another 10, and then 5 times 0.5 is 0.25. I'm missing something here. 10 to 5. 5 times 10 is 50. 5 times 2 is 10. 5 times 0.5. Why is this not working out? What am I doing wrong? Oh no! 10, 12, 50. Oh, 5 times 0.5. It's not 0.25. 5 times 0.5 is 2.5. That's better. Sorry. Something wasn't looking right there, and I wasn't figuring it out. I had the decimal in the wrong spot. 5 times 0.5 is 2.5. Look at that. My estimation skills do definitely need a lot of work. So 50 plus 10 plus 2.5 is 62.5. So the cost is $62.50. Whew. I think I need a break after that. So anyways, that's the idea behind these questions. Instead of taking like a number like 12.5 and trying to multiply it by 5, which is going to be difficult in your head, break it down into smaller pieces and just add them together at the end. That's the idea behind this type of question. And there's no real right or wrong way to kind of break these things down. So where it says try this, 3 times $4.35. I could break that into 4 and 0.3 and 0.05, I guess. That might be easy. 3 times 4 is going to give me 12. 3 times 0.3 is going to give me 0.9. And 3 times 0.05 is going to give me 0.15. Add them together, and I'm going to get 12 plus 0.9 plus 0.5 is 13.05. So that's just a kind of a quick way to do that without a calculator. Is this something that definitely takes practice? Yes. Is it any easier when you're not writing it down to try to do this all in your head? Probably not. Am I going to just encourage you to use a calculator? You bet I am. So if you want to kind of work through this, and if this really makes sense to you, have at her. If it doesn't, you're like, what's the point? I'm with you. Use a calculator. There's no shame in it. All right, let's go to example Unit 1, Lesson 2, page 4. Just want to see how much I want to get done here. This lesson just goes on and on and on and on and on. All right, let's just keep going. Determine the better price in each case where we assume the items are the same. Bananas are advertised at 3 pounds for $2.40 or 6 pounds for $4.20. Determine which is the better buy without using a calculator. All right, let's see if we can do this. Let's just go with this. $2.40 for 3 pounds or $4.20 for 6 pounds. Now it asks us not to use a calculator, and okay, we won't. So 24 divided by 3, instead of 2.4 divided by 3, if I want 24 divided by 3, I know that equals 8. So 2.4 divided by 3 is going to give me 0.8. Or 42, if I think about this, 42 divided by 6 is going to give me 7. So 4.2 divided by 6 is going to give me 0.7. So it turns out that this is the better buy. Now, I do recognize that there is value in estimating doing mental math. But it is 2016. Calculators are easy to find, so I'm not going to spend a ton of time doing this stuff. Go through it if you want. If not, I'm not too disappointed. So there you go, which is actually closer, like questions like this. This 4.9 is really close to 5. So if I had 4.9 times 5, I would say, okay, that's like 5 times 5, which is going to be 25. So which one of these is close to 25? Looks like letter D. 12.25, that's kind of close to 12. 12 divided by 3 is going to give me 4. So I would go C. 49.56 is really close to 50 divided by 4. It's going to give me times 4, sorry. Times 4. It's going to be really close to 200. So, estimating doesn't need to be really difficult. I mean, these don't need to take time. 3 divided by 3, we'll just estimate it, 310 to be 3. It's going to give me $1. So this is the idea behind these kind of estimation questions. They're not terribly difficult. Some of the word ones can be a bit trickier, but it's just estimating. So if you're close, you're good. I'm going to jump down to 19. No, I'm not. I'm just going to leave it. Don't worry about the stuff. The questions all the way down to this one. So this is the top of page 14. So all the estimation stuff, all the do without calculator stuff, don't worry about it. Just go right to page 14. All right, so Matt works in a construction shops at Starbucks each morning, pays $3.80 for a coffee. He's looking to save some money. So you can buy 8 pounds of the same coffee for $38 at a local grocery store. He can make 100 cups of coffee from the 8 pounds. How many more times expensive is the Starbucks coffee than if he made it himself? All right, what I'm going to suggest is we find the price per cup. Now, I know Starbucks is $3.80 for 1 cup. It tells me that right in the question. So if I could figure out this, the rest of this using the kind of bulk coffee. So he has $38 gets him 100 cups. So if I go 38 divided by 100, I get 0.38 per cup. Or 38 cents per cup. Now the question didn't ask which one's cheaper. We knew that buying the bulk coffee was going to be cheaper. But at home you can make it for 38 cents a cup, and at Starbucks it's $3.80 a cup. So the question specifically asks how many times more expensive is Starbucks? So how do I get from this to that? Well, I multiply it by 10. It's 10 times more expensive. And then the second question says approximately how much money would he save on 100 cups of coffee? All right, so let's figure out how much money he saves on 1 cup. And it says estimate. I'll just maybe up top here, there's some room. So he's paying $3.80 at Starbucks. At home it's 38 cents. So if I subtracted these two, just roughly, let's say this was 30 cents. 380 minus 30 is $3.50 per cup is how much money he's saving. If I multiply that by 100 to figure out over the cost of 100 cups, I'm going to get, what's that, 3 times 100 is about $350. And now it's not exactly $350, but it's pretty close. So he saves about $350 by shopping at the store. Matt is now trying to save money on sandwiches. I'll let you figure out which sandwich is the cheapest. I want to do this one at the bottom. So getting back to kind of these unit rate type questions. This tells us that 500 grams is 79 cents, 2.1 kilograms is $3.25, and 3.8 kilograms is $5.35. We need to compare them. So we need to figure out the cost per kilogram or the cost per 100 grams. It doesn't really matter which way you do it, but you need to be just consistent. If you pick cost per kilogram, then that's fine. Now, that's what I'm going to do. I'm going to say, okay, 500 grams is 79 cents. So I get 79 cents per half a kilogram. 500 grams is half a kilogram. So 0.79 divided by 0.5 is $1.58 per kilogram. So that's the first one. The next one, this 2.1 kilograms for $3.25. So $3.25 per 2.1 kilograms. I'm just going to divide those. 3.25 divided by 2.1. So that's $1 and we'll call it 55, we'll round. $1.55 per kilogram. And then the last one is $5.35 per 3.8 kilograms. So I end up with $1.41 per kilogram. So the biggest one happens to be the best deal. That's unit pricing. I think I've had enough unit pricing for today. Did you guys have any questions about unit pricing at all? It's the cost per 1 kilogram, 1 liter, 1 hour, 100 grams, if you want to compare them directly. That is what it is. Nobody has any questions? I just want to take about 10 minutes to talk about sale prices. This stuff is pretty straightforward. I think you guys will be okay with this stuff. You've seen it a lot by the time you've made it to grade 10. So let's just jump right down to number 6 here on page 15. So express the following percents as fractions, reduce where possible. It's funny, once students make it to like grade 10, 11, 12, they kind of forget what percent means. So per is like kilometers per hour, dollars per gallon. Per is just divided by. Per cent. Cent is kind of Latin for 100. You have how many cents in a dollar? You have 100 pennies or 100 cents in a dollar. So per cent just means per 100. That's what percent is. 35%, obviously this symbol represents percent, means 35 out of 100. That's what percent is. Percent, actually quite literally translated. 68%. This means out of 100. That's what this is. So just kind of thinking of the root word percent, what it means, you get that idea. So it's important that you can go from percent to fraction to percent. This shouldn't really be difficult. You just put all those numbers over 100. The next one is express the following fractions as a percent. The easiest way to do this is, if we look at the first example, 4 out of 5, you just go 4 divided by 5 on your calculator, and it gives you a decimal. You get 0.8. Remember, to get it into a percent from a decimal, all you need to do is multiply it by 100. So we get 80%. So 4 divided by 5 is 0.8, and we times 100, and we get 80%. Let's look at 7 over 8. Same thing. 7 divided by 8, that gives me 0.875. That's a decimal. To get it into a percent, I'm going to multiply it by 100%, and I'm going to get 87.5%. 25 out of 20 is a little bit weird because, well, it's going to be bigger than 1. If I had 20 out of 20 on a test, that's 100%. This is 25 divided by 20. Press the wrong button. 25 divided by 20 is 1.25. I still need to multiply this by 100 to get percent. So I end up with 125%. This is 1.25 times 100% is 125%. So you can have percents that are bigger than 100. You can have percents that are less than 100. It doesn't really much matter whether it's bigger or not. All right, what are the major costs for manufacturers, wholesalers, and retailers? Now, the course goes into some detail about how these things are related. So a manufacturer is somebody who builds something. A wholesaler is somebody who takes stuff from the manufacturer and sells it to retailers, and a retailer is usually who you go to buy stuff from. Now, there are exceptions where different companies will wholesale to the public as opposed to retail. This is actually happening in the States right now. I'm a car guy, and I can relate everything to cars, always. There's a company called Tesla. You probably heard of them. They make electric cars, and their inventor, his name's Elon Musk. Anybody heard of Tesla before or seen a Tesla? There's lots in town now. There's probably I see a couple every once in a while. So Tesla, car manufacturer, they decide to, instead of building a car and then selling it to a dealership, and then the dealership sells it to the public, Tesla's just decided, why do we need a dealership? Why can't we just have people buy the cars right from the manufacturer? And that's what Tesla's kind of business plan is. And in the States, there are a lot of people that are really upset. All these car dealers are upset because they can't really compete. Because the way it works is a manufacturer takes kind of raw materials like metal, and if I build a car, I need a bunch of metal, I need a bunch of plastic, I need to melt the metal and make fenders, I need to melt the plastic and make dash panels and airbags and all these stuff. So I take all these raw materials, and I need labor, I need people to build these things. So a lot of plants are kind of automated now, but there's still people along the way. So I take raw materials and labor, and then I sell my cars to kind of like a wholesaler. Now, maybe cars isn't a great example because there's no wholesaler in the car industry, but if you took something like a shirt, if I were to manufacture a shirt, I would take the raw material, I'd take some cotton, I'd weave it into a shirt, I'd get somebody to sew it, and then I'd sell it to a wholesaler. And the wholesaler would take my shirt and they'd say, okay, who wants to buy these shirts, these blue shirts? And they'd say, okay, the North Face store wants to buy it, and Sport Chek wants to buy it, and MEC wants to buy it. And those are the retailers. So the wholesalers, they transport the things, they store the things, and they have sort of labor again. And then you have retailers. Retailers are the ones who sell things to you. So these retailers have rental space, the N in there. And they have a lot of staff to try to sell you things. Maybe like a grocery store would be a good example of this. Let's say, funny example actually that comes to mind. I worked in a grocery store for a long time. We have a place called Sunripe in Kelowna. It's just kind of down the street from us right here. And they take fruit from all over the valley. They take materials, fruit, and they grind it up and they make juice out of it and fruit bars and all sorts of stuff. So there's people and machines. That's the labor. Then that fruit juice and the fruit bars and whatever gets sent to a warehouse, to a wholesaler. And that wholesaler says, okay, who wants to buy my Sunripe juice and fruit bars? And then Safeway, a retailer, says, I want to buy some. And then Save-On's like, yeah, I'll buy some. And Extra Foods and Nesters and all these different retailers buy food from the Sunripe warehouse. Now, the funny thing about Sunripe, and the reason I bring it up, is we live in Kelowna where Sunripe factory exists. And if you go down to Save-On Foods, downtown, or Safeway, just downtown, which is really close to the Sunripe factory, all the stuff from Sunripe actually gets warehoused down at the coast. So because of how the whole system works, your wholesaler that buys all the Sunripe product and gives it to different retailers, they're not always in the same spot. So if you buy a Sunripe juice box, it's likely gone from the Sunripe factory in Kelowna. It gets shipped down to a wholesaler in Vancouver, somewhere in the Lower Mainland, and then it gets put back on another truck and brought back to Kelowna. Just how the system works. Doesn't make any sense, but it's just more efficient that way. So when you are buying stuff along the way, you're paying for all of these things built into the cost. If you could go right to the Sunripe factory to buy juice, it'd be a lot cheaper. But they don't make, they're not in the sort of, I shouldn't say that. You can go to the Sunripe factory and buy stuff, but they're not in the business of selling to the public. Generally speaking, they sell to wholesalers around the province. So that's where this idea of markup comes in. Each step along the way, they need to increase the cost to pay for their labor, transportation, or whatever. So each step kind of marks it up. Now to get back to Tesla, Tesla wants to sell just to the public. Car dealers are like, no, you can't just sell to the public, you got to go through a dealer. So instead of having a markup at a dealer, Tesla can just sell the cars right to the public. And in some states, it's actually illegal for Tesla to sell cars. So I forget what states they are. I think New York State maybe. You can't buy a Tesla in New York State. You have to go out of state to buy it and then bring it back into New York State. It's a big kerfuffle down in the States right now. They're starting to figure it out though. All right, let's not do anymore. It's 11:20 and I think that's enough for today. So there you go. We're up to page 16, which sounds like not a lot, but that's actually about 3/4 of the way through this learning guide. So you can try up to the bottom of page 16. Today's the 25th. That's where we're at in terms of this unit. You need to definitely finish off unit 3 stuff if you haven't yet. We're going to finish off this unit tomorrow, or not tomorrow, next class on Thursday. We will do sale pricing and, oh come on, Costin, look at these questions. 20% as a fraction or decimal. Take you about 2 seconds to do these. It looks like a lot. And remember all of this estimation stuff? I said don't worry about it. Where did that start? Right here. Calculate approximate cost without a calculator. So I don't want you to worry about any of this estimation stuff. It's in there. If you want to do it, you can. But that's about 4 or 5 pages, or maybe 3 pages or so that you don't even need to really do. So where it says estimate the cost of this, there you go. Math isn't for everyone, Costin, I'm with you, but we got to get through the material one way or another. So next day we'll do a little bit more sale pricing stuff. We'll do some currency conversion, and that'll be it for unit number 1. So there you have it. Have a great afternoon. We'll see you guys on Thursday. Bye-bye.